Alright, so this is Chapter 10, Section 4, the Hyperbola. Hyperbola is a collection of all the points in a plane, the difference of whose distances from two fixed points is called the foci, is a constant. I like to think of it the same way as ellipse, the same way as a parabola. Your hyperbola always wants to wrap itself around the foci. So they curve towards their foci. You have a center. The axis that your foci are on is called the transverse axis, and the other axis is called the conjugate axis. Our first learning objective is to analyze hyperbolas with center at the origin. So we're starting at the center. All right, so when we're centered at the origin, we can say the distance from the focus to a point minus the distance from our other focus to that same point is equal to plus or minus 2a. Our foci are at negative c comma 0 and c comma 0. The equation of a hyperbola with a center at 0, 0 and a transverse axis along the x-axis. So the way you can tell which axis you're on is it is the positive value. So here x squared over a squared minus y squared over b squared, whichever one is negative is not the transverse, it's the positive one. An equation of a hyperbola with center at 0, 0 has foci at negative c0 and c0. The vertices are at negative a0 and a0. And this is related to this a directly. We know that b squared is equal to c squared minus a squared. And it looks like this. All right, so let's put an equation together of a hyperbola with a center at the origin and a focus at 3, 0 and a vertex at negative 2, 0. And we're going to graph it. So we know since our focus is at 3, 0, we know c is 3. Because our vertex is at negative 2, 0, we know that our distance is, or a, is equal to 2. So let's go ahead and use those two items to find b, so we can put the equation together. So we have b squared equals c squared minus a squared, which is 3 squared minus 2 squared, which is 5. So my equation is x squared over a squared minus y squared over b squared. And when we graph that, we graph our focus at 3, 0. It's a matching focus at negative 3, 0. Our vertex at negative 2, 0. And it's matching vertex at 2, 0. And then we go ahead and plug in 3 for x here and solve, and we get y is equal to 5 halves. So our point to tell us how wide or narrowly our hyperbola opens is at 3 comma 2.5. 3 comma negative 2.5. Negative 3 comma 2.5 and negative 3 comma negative 2.5. All right, so with a hyperbola, In order to graph it on your calculator, we need to solve it for y. So we end up subtracting x squared over 4, we multiply by -5, and then we take the square root of both sides. So when we do that, we get two answers, a positive answer and a negative answer, because when you take the square root of both sides, you get plus and minus. So we get plus root 5 times the square root of x squared over 4 minus 1, and y2 is the negative version of that, negative root 5 square root of x squared over 4 minus 1. So here's what we hand graphed, and here is what it looks like on your graphing calculator when you do y1 and y2. I don't mind using the calculator to verify your graphing, but I find that it's not any easier to solve for y and graph it on a calculator than it is just to plot the vertices and the foci and do it by hand. All right, so we are now going to be given an equation, and we're going to have to find the foci, vertices, and graph. So if we have x squared over 16 minus y squared over 4 equals 1, we know that a squared is this term right here, in front, what's underneath the positive term, and then b squared is the denominator of the negative term. We know that c squared equals a squared plus b squared, or 16 plus 4, which is 20. So we know that c is equal to square root of 20, which reduces down to 2 root 5. So our foci are at plus or minus 2 root 5 comma 0. Our vertice is at a comma 0 and negative a. So if a squared is 16, negative a would be negative 4, because square root of 16 is 4. And it's also going to have a vertice at the positive version of that, 4 comma 0. When we graph that, we graph the vertice, the foci, and their negative counterparts. And then we go ahead and plug in 2 root 5 to find what value. So we plug in 2 root 5 here. Remember, that's 20. So it's 20 over 16 minus y squared over 4 equals 1. We subtract 20 over 16 from both sides. We multiply by negative 4 and then take the square root to find that. It gives us 1 and negative 1. Okay, so now what happens if our hyperbola opens up and down? It just means that our y squared is now the positive 1 and our x squared is now the negative 1. Whoever's positive gets the a value. Whoever's negative gets the b value. B squared is still equal to c squared minus a squared. And it looks a little something like this. Our foci are now at, instead of being at negative c comma 0, it's at 0 comma negative c, because our axis changed. And the vertices are at 0, negative a, and 0, a. All right, so now we have an equation that is all multiplied out, and we need to make it look like a hyperbola. So the first thing we want to do is, we see that our leading term is the y squared. So he is going to have his major, the a is going to be along, and the foci are going to all be along on the y-axis. Y is first, it's on the y-axis. We want it equal to 1, so I'm going to go ahead and divide by 4. When we divide by 4, we get y squared over 4 minus x squared over 1 squared equals 1. That means a squared is 4, b squared is 1, and c squared has to be 4 plus 1, which is 5. So our vertices are at a, 0, comma a, and 0, comma negative a. And that's at 0, negative 2, and 0, 2. Our foci are at 0, comma c, and 0, comma negative c. So that's at 0, comma plus and minus root 5. Let's go ahead and draw all these. We can use our b value to get our narrowness. So they're not doing it here, but I use the box method. So if you draw in your A, so here's 1 and 1, and then go ahead and go through your vertices. You can have a little box, and then if you draw diagonals through your little box, you'll get how wide or narrow your hyperbola is going to be. And then you don't need these coordinates here. I find it easier to draw the box than to find the coordinates of the lattice rectum. All right, so if we know we have a hyperbola with a vertex at 0, 2, a foci at 0, negative 3, and 0, 3, we want to find the equation and graph the equation. So we know if our vertex is at 0, 2, we know our A is going to be along the y-axis. So we start out with this general equation. And we know that A is going to be 2. Having a foci at negative 3, 3, we know that C is going to be 3. So we use the equation b squared equals c squared minus a squared to find our b squared, which is 5. And we throw the a squared and the b squared in the equation, and we get y squared over 4 minus x squared over 5 equals 1. And then we throw that information down on our graph, vertices at 0, 2 and 0, negative 2. If this is me, square root of 5 is about 2, so here on my calculator, 2.2. So my box is going to be here, 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 here. And then I draw the vertices, or I draw the diagonals of my box to give me how wide my hyperbola opens. And throw that down. Make sure you put your foci on your graph, and you're good to go. Keep pressing the wrong button. Record. All right, so now we're gonna I let the cat out of the bag. I've already told you how I find the asymptotes of a hyperbola, but you can actually write the equation for the asymptotes of the hyperbola. So here's this box method of which I spoke earlier. And then the asymptotes of your hyperbola are going to be these diagonals of your box. The equation of your diagonal is going to be y equals b over ax when we have our x leading, and y equals negative b over ax. And if you have if you're on the y-axis, opening on the y-axis, y squared over a squared minus x squared over b squared equals 1, then your equation of your line is y equals a over bx, and y equals negative a over bx. So with this equation, these are your asymptotes. right, so let's take a look at a hyperbola. Y squared over 4 minus x squared equals 1. Since y squared is positive, the transverse is along the y-axis. So we know that a squared is 4 and b squared is 1. We can go ahead and find our c squared so we know where our foci are. 4 plus 1 is 5, so we know c squared equals 5, and c is equal to square root 5. Our center is 0, 0. Vertices are at 0, negative 2, because a is 2, and 0, 2. Our foci are at 0, comma, plus or minus root 5. We are now adding the asymptotes to our analysis. There, y equals a over bx. So a is 4, b is 1. Sorry, a is 2, b is 1. Let's go back here. A is 2, b is 1. And we get 2 over 1 is 2, so our asymptote is at y equals 2x, and y equals negative 2x. So we go ahead and graph those things. So we graph, once we have the asymptotes, we no longer need to find the other point to tell us how narrow or how widely our hyperbola opens. So we have our vertices at 0, negative 2, and 0, 2. We have our box that goes, because A is 2 and B is 1. So our box opens like this, and our asymptotes are along the diagonals of that box. We throw down our vertices. We've got our foci at 0, comma, negative root 5, and remember root 5 is 2.2. So it's just inside our vertices. All right, so now let's go ahead and move our hyperbola from the origin to anywhere in space. So we're going to have a new center, and it's going to be at HK. So instead of, we're going to rearrange our formula just a little bit, adding and subtracting the H and K into each of the pieces. Hold on, I'll get it back. I keep pressing the wrong button. All right, so let's find an equation for the hyperbola with center at 1, negative 2, and 1 focus at 4, negative 2, and 1 vertex at 3, negative 2. Graph the equation by hand. So once again, I recommend throwing these coordinates onto a graph first to determine where we open. Some people can see that just by looking at the numbers. I need the graph to kind of give me the direction, so that's how I would roll. But the center, focus, and vertex are all on y equals negative 2, so the transverse axis is parallel to the x-axis, meaning that our x term will go first. We can find H and K because they give it to us. They say the center is at 1, negative 2. So H is 1 and K is negative 2. Now we're just going to plug into the formulas. The distance from 1, negative 2 and the focus, which is at 4, negative 2, is 3, because the difference between 1 and 4 is 3. And the distance from the center to the vertex, so the center's here, vertex here, distance from 1 to 3 is 2. So we know C is 3 and A is 2. B squared is equal to C squared minus A squared. That's 9 minus 4. Oh, doggone it, B squared again is 5. So we can put together our equation, x minus 1 squared divided by 4 minus y plus 2 squared divided by 5 equals 1. we throw all those things down onto a graph, and we get a hyperbola that looks like this. All right. Let's take a look at negative x squared plus 4y squared minus 2x minus 16y plus 11 equals 0. I'm feeling like we might have to complete the square on this bad boy twice. Super fun. Okay, so if we put everything onto the right-hand side and group our x's and y together, remember I need each squared term to have a coefficient of 1. So you're going to factor out whatever the squared coefficient is. So in this case, for y squared it's 4, and for x squared it's negative. So you take your b term divided by 2. 2 divided by 2 is 1. 1 squared is 1. I'm going to add 1 here and then distribute the negative to it. That's technically, I am adding a negative 1. So I'm going to go ahead and put a negative 1 on my right-hand side. Here I take this b term, which is negative 4. I divide it by 2, which is negative 2. And then I square it to get positive 4. But I have to distribute. 4 times 4 is 16. So really I'm adding 16 to both sides, which is true when I put a plus 16 on the right. All right. I then rewrite each of these terms as a squared term. And negative 11 minus 1 is negative 12, plus 16 is 4. That's turning out nice. So then I divide both sides by 4 because my equation says equals 1. And I put my positive term first and my negative term second so that I have it in proper hyperbola form. I can see that my center is at 2, it's at negative 1, 2. My A is 1 and my B is 2. And then my C, surprise, surprise, is square root of 5, or C squared is equal to 5. So my center is at negative 1, 2. My vertice is at negative 1, 2 plus and minus 1, which turns out to be negative 1, 1, and negative 1, 3. My foci are at negative 1, 2 plus or minus root 5. So you just take your center and you add, in this case we add our A, and in this case we take our center and we add and subtract our C. And then we throw down the graph. Alright, so our last learning objective is the applied problems involving hyperbolas. Hello. Look at figure 48. Suppose that 3 microphones are located at O1, O2, and O3, and the foci of the 2 hyperbolas. Oh, so these are foci, and these are foci. In addition, suppose that a gun is fired at S. So we're here. And the microphone at O1 records the gunshot 1 second after the microphone at O2. Because sound travels at about 1,100 feet per second, we conclude that microphone O1 is 1,100 feet farther from the gunshot than O2. We can model the situation by saying that S lies on the same branch of the hyperbola with foci at 0, 1, and 0, 2. Do you see why? The difference of the distances from S to O1 and from S to O2 is the constant 1,100. If the third microphone at O3 records the gunshot 2 seconds after O1, then S will lie on the branch of the second hyperbola with foci at O1 and O3. In this case, the constant difference will be 2,200. The intersection of the two hyperbolas will identify the location of S. This is all just information. All right. New problem. Suppose that two people standing 1 mile apart see a flash of lightning. After a period of time, the person standing at point A hears the thunder. 1 second later, the person standing at point B hears the thunder. If the person at B is due west of the person at A, and the lightning strike is known to occur due north of the person standing at point A, where did the lightning strike? Best thing to do is center your problem on the origin. So we got north-south is our X and Y, east-west is, north-south is our Y, east-west is our X. After a period of time, the person standing at point A, so these guys are 1 mile apart. Remember, 1 mile is 5,280 feet. So from foci to foci is 5,280. That means that the foci are at 2640, 0 and negative 2640, 0. We know that sound travels at 1,100 feet per second. We just read that in the last problem. So the person at point A is 1,100 feet closer to the lightning strike than the person at point B. Since the difference of the distance from XY to B and the distance from XY to A is the constant 1,100, the point XY lies on the hyperbola whose foci are at A and B. So we open along the x-axis, so we have x squared over a squared minus y squared over b squared equals 1. We know that 2a, because we know that these guys are 1,100 miles apart from here to here. So a has to equal 550 because 2a is equal to 1,100. 2c is 5,280, so c has to be half of that, 2,640. We can see that from our graph pretty easily. And b squared equals c squared minus a squared. So b squared is 6,667,100. So we plug in a and square it, and we plug in b squared, and we have the equation. We plug in 2,640 for x, because we definitely know that that is where our lightning is striking. We get a value, I think we get negative 23.04, and we subtract it from both sides to get negative 22.04. Then we're going to multiply both sides by 6,667,100, negative version. Y squared is 146,942,884. We take the square root of both sides, and we get y equals 12,122. So the lightning occurred 12,122 feet north of the person standing at point A. And that is all we have for today.